This is another question from the AQA Paper 1, and this one's about searching search algorithms. So there are two search algorithms you need to know about for GCSE. One of those is the linear search, which is the one it's talking about on the left-hand side here, and one of them is called binary search. And so what it's asking you to do here for 3 marks is to state the comparisons that would be made when the linear search algorithm is used. Well, the linear search algorithm, we're searching for 8, the value 8. So what it does is start at the left-hand side and it says, is this value 8? So is 4 8? The answer's no. So we compare 4 with 8. Then we'll move along, we compare the next value. We compare 7 with 8. And then we come along on the next value and we compare 8 with 8 and we find a match, and that's means we found what we were looking for. So we took three searches, or 3 comparisons should we say, to find the value for linear search. On binary search, so a binary search algorithm is divide and conquer, so it's it splits the list of items we're finding in half every time. So the way that we do that, we've got 7 items here. So we choose the middle item. So the middle item's 13, and we say is compare 8 with 13. And instead this time of just saying yes it is or no it isn't, we say, was 8 smaller than 13 or bigger than 13? And we find out it's smaller than. So that means we can get rid of all this part of the list. And now we've got a list that is 4, 7, and 8. And so we choose the middle value again, which is 7, and we compare 8 with 7. And instead again of just saying is it the same, we say is it smaller or bigger? It's bigger, so we get rid of that part of the list, and then we compare 8 with 8, which is the last value, and we say we found it. So binary search, in this case, we took the same number of comparisons. We compared with 13, then with 7, and then finally with 8 to find it. So we took three comparisons again. So it was looking for you to show that you understand how the algorithm works. So for this question, it's just state the comparison. So we could have just got away with saying we compare 8 with 13, 8 with 7, 8 with 8. That's all we have to say. We don't have to say anything else on that. So then the next part of this question at the bottom here, which, in my opinion, is not the greatest of questions. So why is binary search considered a better algorithm than linear search? Well, why is it a better algorithm? Well, it's a better algorithm if we're searching through lots of different numbers, and it works only if the numbers are sorted. However, we could say that for large data sets, binary search will, on average, make fewer comparisons. And that's because of this divide and conquer idea. However, for small numbers, linear search is okay. There's not anything wrong with linear search for small amounts of numbers. Why is it considered a better algorithm? Well, this is a good answer to this, but it's not the full story, of course. So if we were thinking about the 2 algorithms, then they might look like this if we did a graph of them. So we get linear search, which is totally dependent on the value of n. So these are numbers. So that's the quantity, and this will be time. So linear search, totally dependent on that. We'd call that O of n if we were doing this for an A-level question. However, for binary search, you're going to get a shape something like this. So this is because binary search is one of these divide and conquer algorithms. So it starts off, it's not quite so efficient for small numbers, but quickly becomes much more efficient. So this is O of log n. So if we were doing this for A-level, we'd know this was called O of log n, and we'd know how this works. But just as far as we're concerned for this GCSE question, I'm just making the point that when we say something's better, we do have to be a little bit critical of that, I suppose. So for linear search, if we've got an array that's got numbers like this, and we're looking for number 4, then we're going to find it in one comparison. So that's best case. If we are using binary search on these numbers, first of all, we'd have to sort them. So we'd get 1, 2, 4, 7, 9. And then if binary search was looking for 4, it'd split the list in half and look at the middle value. So again, it would find it in one comparison. So best case scenario again. So from that perspective, you could say both algorithms would find it in one comparison for that best case scenario. But you do have to bear in mind that we sorted this list as well. So it does take some time to sort the list too. So I wasn't trying to make this more complicated than it is. I was just being slightly critical of the idea of what is a better algorithm, because some algorithms are better for one purpose and they're not so good if that purpose changes. So this is exactly the case with this.